How can we equip 3D assets with the additional touch modality? Given a text or image input, we first generate a base mesh with albedo map, using off-the-shelf methods like Wonder 3D. To add tactile information, we synthesize a 2D tactile normal map from an exemplar tactile data. We can render these maps directly on the mesh, but visual and tactile textures may become misaligned, especially when color transitions imply geometry change, as seen in the strawberry example. To align visual and tactile textures, we use a 3D texture field that map each point to paired albedo and tactile normal values for joint optimization. We optimize the 3D texture field by querying it from random viewpoints and minimizing the rendering loss. However, vision and touch have very different spatial resolutions. To match the scale discrepancy, we sample visual cameras PV from a distance and tactile cameras PT close to the surface to render small patches. For initialization, we use the base mesh albedo map to supervise albedo rendering and the synthesized tactile normal map for tactile rendering. However, initial textures may not align. Thus, we refine them using a multi-step denoising pipeline. Specifically, we use a normal conditions control net to refine full color rendering, and use a customized TactileDreamFusion model to refine the tactile patch rendering. Compared to prior methods that focus only on vision, we generate tactile normal maps from touch data and refine them on patch level. High-resolution normal maps further guide visual generation, improving cross-model consistency. After optimization, we can query the texture field from any viewpoint and export it to UV maps to get a mesh with aligned visual and tactile textures.